Good afternoon, everybody. It's David Schlotthauer here in the home weather office, back from Santa Cruz from my little birthday surprise well, not really a birthday surprise, but we had some king tides, but we're back here in the office. We have a big storm that we are really watching, not only for the Midwest, but this live stream really focuses and tails into the northwestern United States, including for California. In fact, Southern Oregon and Northern California will be in the biggest brunt of this storm system that is setting up. Another one of those big atmospheric river type systems that are going to set up. It's going to be really, really significant. We're talking big time rain and some big time extreme winds with this next big storm system that's setting up. And not only that, some really heavy mountain snowfall for the higher elevations, because this is going to have enough cooler air with it where we are going to have to keep an eye on how low will the snow levels get. But really quickly, I did not want to forget about sharing the forecast right now for the Midwest, and then we're going to focus on the rest of this live stream, because I did not want to forget about you all living in the Midwest because of how active the weather pattern is there. So of course, we have this Midwest storm, high plains severe weather event, mainly down here, bringing some severe weather, some spin ups, maybe some large hail with that. This is going to be absorbed, or it's going to kind of fall apart as it generally gets absorbed up here in the northern tier of the United States. But what we have going on across the northwestern U.S. is there's going to be a big system that is going to set up here, and we're going to really get into more details on what we're looking for here on satellite. But I just wanted to bring that all to you, that there is severe weather, there is some heavy rainfall and flood concerns with the system in the Midwest. You all need to take this one a little more seriously, because that's going to have some heavy rain with it briefly, and depending on where you're at. So let's actually take a look at with what we're looking at now. Currently, we're going to use a couple of satellite tools here. We're first going to look at College Dew Page, and then we're going to be looking at Zoom Earth, which is a really good satellite product that I like to use too. So as you can see here, if we play this through, there is all these popcorn-like clouds. This is instability. There is colder air moving over these relatively warmer waters. Not that they're 80 degrees Fahrenheit warm, but they're warmer than the surrounding atmosphere, and what you get is instability. So we get these showers, these thunderstorms that do pop up above these waters, and some of that moisture does move into Washington. In fact, there have been some thunderstorms in Washington today. I have a friend that lives in Arlington, Washington. A couple of viewers, I'm sure, that are watching this live also in Seattle. We can see the afternoon surface heating allowed these storms to really blossom, some of these cumulus thunderheads. This is not ahead of that system. This is kind of in the wake of the last system that has went through that destabilized the atmosphere. But also there is some snow on the Olympic Mountains here. Pretty interesting to see that. So if you look southwest, you might see some snow there in those mountains. And then here comes more storms that could dump more snow for those areas. But zooming out, looking out now, we have a very big system that is getting ready to set up shop here. We have a baroclinic leaf type structure here. So this smooth cirrus, this is going towards California. In fact, it is partly to mostly cloudy outside right now, part of the cirrus clouds that are moving in from northwest to southeast. But when we look at what we're seeing here, this is actually where the low is forming underneath. Actually, it's roughly about in here. So that yellow circle that I've put in is where our low pressure center is forming. We got northerly flow here, and then it kind of jerks out like this, part of that setup. And then you get the flow that kind of bends out like this. This is a very classic optimal setup for this low to be in, for where it can actually deepen pretty substantially into the point where we're going to see a 45 plus, perhaps a 45 millibar drop in pressure in 24. Actually, no, wait. It's going to be, 45 millibar drop in pressure in 24 hours. That is pretty alarming. That is absurd. You don't see that very often. And this is going to be developing within a very intense baroclinic jet that is racing across. You can see the flow doing this very strong insanity jet, about 120, 140 knot jet at 250 millibars, helping to form these cirrus clouds. And as we play this through, you can see the leading edge of this cloud cover. Watch what happens. You could really see it right here. In the last few frames, really start to see that shape up. And as that does develop, the pressures are going to fall rapidly because we're getting stronger divergence aloft. Remember, air has to go somewhere. It doesn't go into one space, right? When you have divergent flow aloft, okay, so at 250 millibars, we have flow that looks more kind of like this. Even so, doesn't look like a whole lot of divergence. There's enough to actually get a surface flow to form underneath all of these clouds that you see. And if we look at this on a current surface analysis, this is courtesy of zoomearth.com. There will be a link. I don't think, there's a link. It should be in the description. And you can see there is where we have the surface flow right now. This little piece of energy, what I call a little glocket of energy. Remember that term that I would use with most of these storms is glocket. This little piece of energy where we have convergence at the surface, where we have divergence aloft. This is where we are seeing that baroclinic leaf right on the edge of that. And that's where we have our surface flow that is going to be exploding, explosive genesis, not rapid deepening. This is going to explode in intensity. And in fact, if we look at the pressure right now, this is on the GFS model. This should be the latest run, right? Let me make sure. Yeah, this is the latest run. Right now, it's at around 1,010 millibars. And you might think, man, 1,010 millibars, David, what are you talking about? It is not that strong at all. Wow, 1,010 millibars. But watch what happens here. Watch when I play this through. You can see how the pressure is going to drop over the next, this is through the next couple of hours. So in 2 hours, it's going to go from 1,010 to 1,007 millibars. And look, really what happens here overnight is it really deepens. And then actually this is 7:50 p.m. Yeah, this is 7:50 Seattle time, goes down to 1,002 millibars. And then look at this. This is through 9 o'clock tonight, local time for Pacific time, goes down to 1,000. And then it really deepens. Look at this. Look how deep this gets. The isobars really drop quickly. 990. That is still relatively high. It really comes in tonight when the system really bombs out. And you can see how deep it really gets down to 978 millibars. And then it really deepens tomorrow. Look at this. It really bombs out. So it's really about between 4 in the morning and about 9 in the morning when the quickest deepening actually happens with the system. And the ending result here is by 9 in the morning, it's a 9:59. It's only going to get lower. So if we play this through, you can see, look how deep it gets. 9:52, and it still gets deeper. It still gets deeper. I mean, this is ridiculous. 941 millibars. I mean, that is a very tight pressure gradient. I mean, something you don't typically see at all with any type of system like this. This is, for one thing, we see 950 millibar, about 950, 960 millibar systems in the North Pacific. You know, they do bomb out, but a system that bombs out like this is unusual. It doesn't happen very often. And the last time I could remember something like this happening is a Columbus Day storm of 1960, 1950. Maybe you could help me with that one. I'm Keith Evans. But it was like in the mid 1900s, since we had a system that bombed out like this, where it started at like 1,000 something millibars and it got down to 940 millibars. Actually, it didn't even get that low. And on the GFS here specifically, it holds out a little bit. It gets about like, it gets down to even 940. Now, there have been some, 1962. Thank you for the correction, Keith Evans. So, yeah, 1962, the Columbus Day storm. That is in the books of, this is almost a century, roughly near a century. No, not really near a century because it's not 2062, but you get the idea. It's serious. It's a very intense storm. There have been some model runs, not on this particular model, had it down to even as low as 936, 937 millibars. That is in the books of a Cat 4, high-end Cat 4 hurricane, but it's not going to be a Cat 4 hurricane. The wind field on this is a lot bigger than a hurricane in itself. But nonetheless, this is going to have some serious winds with it. Remember, let's go to today. All right, that's where the system is. All right, 1,006 millibars. Actually, let me see here. Hold on. So let me see where the pressure kind of bottoms out at. Let's see. So it's about 940, 941 millibars. Let's go back. That's where it is pretty much. So if we subtract this, I can tell you how many millibars this is going to drop. So if we go 1,011 millibars minus 940 millibars, that's 71 millibar drop. Wow. A 71 millibar drop in pressure. Let me make sure I got that correctly. Yeah. 71. It's on my phone. 71 millibar drop in pressure in 24 hours. Keith Evans, I hope you hear that correctly. 71 millibar drop in pressure in 24 hours. So this is just absolutely extreme. Unheard of system at all. And I was talking to Keith Evans earlier, the one that lives near Seattle. Not going to disclose your exact city, right? We want to be secure here on the channel. But he was telling me that if this was any closer, this system in itself, this would have been a disaster, a serious disaster for the Seattle metro area. It is going to be significant enough with pressures that are this low. But it could be a lot more significant if this thing was a lot closer. I mean, if we actually get our ruler out, yeah, if this was like 200 miles closer, this would have been a lot more significant. So it's a good thing it's not going to get that close, but still, it will be close enough to get some serious winds with this system. That's a very tight gradient, by the way. Those easterly winds are just going to be intense, really howling. And the system continues to really be deep. In fact, if we go throughout the day tomorrow, you can see how the pressure does continue to drop. And it kind of levels off and it slowly starts filling in. But still, 942 millibars, that is a serious system. So now what does this look like when we look at the, let's look at this. So this is a satellite representation of what the system is actually going to look like. Let me go into the north central. Maybe that will, okay, no, that's not going to help. Will this even work? Hold on. Let's see if we could, darn it. It's not going to give us a good view. So let me see here if I can get a better view. Maybe the Gulf of Alaska. Okay, this is a lot better. There's Washington, there is Oregon, Northern California, and this is the baroclinic leaf that we're looking at. So again, just to show you in context of what this is actually going to look like, look at how this sets up right here. So you get your baroclinic leaf here, or what we call isotropic ascent that happens here. You get this shield. This is a very classic, very augmented, aggressive setup of divergent flow happening in the mid and upper levels of the atmosphere. And so when we go forward here, look at how this thing just balloons. It really just blows its top. You get this very classic northern baroclinic leaf of a shield of heavy rainfall and strong winds. This is going to slam well into Oregon, especially into California, where that atmospheric river is going to be nosing in. We'll be looking at the Pewaps here in a little bit. There's going to be two sides to this. I think more of the Washington area, like Seattle to the north, will probably get the more windy part of the system, and even the Olympic Mountains. Not so much of a big flood rain threat there. There will be some flooding because of maybe some storm surge because of how strong the winds are going to be. But it is going to be mainly a big, massive wind storm up here. The rain is going to be significant in itself, but nothing like, say, Southern Oregon and Northern California. That's where the brunt of the heaviest rainfall will likely take aim. So there's two systems. Super windy side, that's to the north. That's in the Washington area and along the coast here of Northern California and Oregon. And then you get the heavy rain side as well, and then, of course, the high elevation snow. But believe it or not, this may not look very like, man, from a satellite perspective, it's not a hurricane, but this is going to have a tremendous amount of wind energy. I mean, so much so that surf could build over 30 to 40 feet. We could see 30 to 40 foot waves out here, and some of those could break on the shore along the say the Olympic side here of Washington, as well as, say, Vancouver Island. There could be some breakers here approaching 60 to 70 feet. That is enough to lead to exceptional beach erosion, coastal damage, pier damage, that sort of thing. This is something to not mess with at all. This is a serious system by all means, an extremely explosive bombing cyclone that this area of the Pacific has not seen in nearly a century, since a Columbus Day storm of 1962. And seeing a system like this, only imagining if this was closer to Washington or it was further south, like right off the California coast, this would be a big, gigantic wind machine by all standards. And in this case, it is going to be a big, gigantic wind machine for the coast of Oregon and especially the metro area of Seattle, Washington, including the Arlington Heights, as well as some of these canyons. And I'll be showing you a little demonstration on that in a second. So let's actually go back to the south here, and let's look at the northeastern sector. Here, actually, you can see it a little bit better. So you can see the whole, actually, no, wait, you can't. Let me full screen this because I have that laid out differently. So this is the full size of the system. Nice, good AR. You can even see the moisture tapped all the way back here. Not really from Hawaii, but well, some of the moisture gets fed into this, and then it just aims right clearly squared into Northern California. And yes, here we're on a tightrope. We might see a half an inch of rain, or we could see 4 inches of rain out of this. It really depends on where that AR stalls. Okay, where the hurricane will stall. Not really a hurricane. It almost could look like a hurricane with its rain amounts. So this is what it looks like. So this is PWAT, or precipitable water. How much water is in the atmosphere? So water by itself, okay, I want to just do a little lesson here. Water by itself does not lead to ferocious rain amounts. I want to be clear about that. So you might see, let's go in the Gulf Coast here. So let's go and look at the Gulf of Mexico for an example. So you have a lot of water here, okay? And if we go to actual precipitation amounts, there's not a whole lot here, okay? And the reason why there isn't a whole lot of rain, despite all of the moisture that we're seeing here, is because there's not enough lift. You need lift in the atmosphere. Now, the lifting process with this is a little different than what you get with a severe weather event. You need convergence along a cold front to get these storms to get triggered and stuff, and enough lift to lift the cap and stuff. But what you need with an atmospheric river is a lot of jet stream baroclinic energy. You need a lot of lift, isotropic lift along that baroclinic zone for the moisture to be lifted, for it to be forced aloft, for it to condense into water and to get these clouds that drop a lot of rainfall. So in this case, this is an AR, but there's not a whole lot of lift. The lift is removed more to the north. So in a similar sense, this is what we're seeing in California. This AR, as it sets up, there's going to be a lot of lift that is going to squeeze out. It's going to wring out all of the water throughout these coastal range mountains, the northern portion of California, Oregon, into Washington. And now this moisture doesn't seem like, oh, it's a lot lesser than the Gulf of Mexico. Well, of course it is. But when we look at our precipitation, our PWatt anomalies, this is pretty significant here. The degree of lifting is going to compensate for this at around 140 to about 180% of normal. That is literally about 1 to 2 times the standard deviation with all of this moisture that is going to be funneled. It's going to be a fire hose here headed into Northern California and Southern Oregon. Now, up here is a little different because you're going to get more southerly flow, so it's not going to hit the coastal range mountains perpendicular to with what, say, Northern California is, which explains why these areas up here are not going to see the most significant amount of rainfall totals, but you will still see, like, say, 3 to 5 inches of rain in some of these areas, versus down here, it could be measured in feet. In some of the higher elevations of northwestern California, with this atmospheric river hitting the mountains here perpendicular, we could see rainfall accumulations greater than 16 inches, 16 to maybe 24 inches in some of these rainiest prone areas. That is pretty phenomenal when you think about it, coming from an atmospheric river. So this moves further south, you can see it's going to actually amplify a little bit more. Now, where this sets up is going to be extremely essential, okay? Let's actually zoom into California a little bit here. Sorry, we'll look at the Pacific Northwest here again in a little bit. But where this atmospheric river really funnels in, it looks like here on the Euro, we are going to get quite a bit of PWatts here, up to around an inch or so, maybe an inch and a quarter around the Bay Area, which is enough to bring out a lot of moisture. And the concern about these atmospheric rivers is just not how big they are, but how slow they move. So as you can see, when this atmospheric river hits Oregon, it's going to be it moves in and it moves out. So you can see how progressive this AR is when it hits Oregon. The concern here is when it gets into Northern California, it stalls. A stalling atmospheric river here is no joke. It is no joke. It rains for hours and hours and hours. It doesn't stop raining. It could rain really hard for a given location for 24 hours with rainfall rates greater than a quarter to a half an inch an hour. That's enough to really add up the rain totals pretty quickly. And look, it just sits. It just sits. It doesn't move. It doesn't go anywhere. All right, it just sits and sits and sits. Now, it does retreat a little bit northward because there's a little bit of ridging that does build in from the southeast. But it's not going to move far enough north to where these areas don't get any more rain. It's going to just be a fire hose up here in Ukiah, in Eureka, Crescent City. If you're up here, say in Red Bluff, if you're in Redding, It's just not going to stop. This is a big concern. Not Reading, Pennsylvania at all. Okay, this is a different Reading in California. And then look at, this is more amped up. This is narrower, more progressive, but look at this. These P watts are exceeding 1.5 inches. This is for Friday, 4 days out. This can change a little bit in time, but this is from the Euro model showing a really intense AR moving right through California. And then get this, it just kind of stalls here and then it hits again. This is Sunday. So we're looking at a time window here essentially from, well, maybe tomorrow afternoon all the way through maybe Saturday or Sunday next week, where the rain is not going to stop. When it rains, it's going to pour, and it just is not going to let up. Especially up here in the north. Well, it will add up eventually on Sunday, but now the AR has to go somewhere. Now it's focusing itself in central and northern-ish California. Again, for the Central Valley, for these higher elevations of the Sierra. And that's the furthest this goes out. This is the 18Z run, by the way, of the Euro. This has trended north a little bit. But if we looked at our, or if we just look at our 12Z model guidance, you can see where that AR really aims, which, by the way, San Diego gained 1.6 of P watts, pretty significant for late November, nearing Thanksgiving here. So this could be a pretty big flood event by all standards in Northern California and Central and Southern Oregon, especially where this atmospheric river really takes aim. All right, something to really be concerned about. Now, looking at our P watt anomalies, percent of normal, anything above 250% of normal is pretty impressive for mid to late November. And look what happens. It just really amplifies, especially right here, almost 300% of normal. And this gets further south. It weakens a little bit, and then really it amplifies a little bit. Some of these areas here in the Sierra by Sunday could have P watt anomalies exceeding 375 to even 400% of normal. That is way up here. That is in the 90th percentile for this time of the year. That's a lot of moisture hitting a given area for a long period of time. I mean, we're talking Tuesday through Sunday, maybe even into early Monday next week. Now, the standard deviation here, I wanted to show you this. Actually, we're going to look at the entire West Coast on this one. So you can see the P watts up here in Washington, not all that unusual. About between 1/2 to maybe 3/4 of the standard deviation. All right, in sigma. And again, this is for the Pacific Northwest and California. But it's, again, Northern California. I want to really emphasize it. And based on the latest model guidance here, this has shifted a bit further south, just a little bit further south. I have a feeling where this is probably going to end up headed. Probably going to focus right over here, more so likely, based on our P watts. But this is 3 times the climatological mean. This is 3 times the standard deviation, which is something that which is what you don't want to hear about. You really don't. This is 3 times the climatology for this time of the year, and it gets even up here to 4 times the climatological mean in Northern California. All right. Warmer air holds more moisture, and that's why these P watts are going to be higher, because the air is going to be more moist, a little warmer than usual. It's going to be a little more moist than usual. And this really aims, look at this. This is even almost 5 times the climatological mean right here. As this moves further south, this is quite extreme. I mean, this is roughly 75 to 90, in the 75th to 90th percentile. This goes further south. And then if we get a resurgence of that moisture, some of these higher elevations here could even be approaching 5 to 6 times the climatological mean. So in other words, a lot of moisture is on the way for California, for Northern California and Southern Oregon primarily. And yeah, oh wow, I'm seeing this for the first time. Wow, this is, am I looking at that right? That's a 986 millibar system. Wow, that is a very strong system right there hitting California. Oh man, this would be a big time storm. Actually, I am looking at this for the, it did look energetic on the PWAT though on here, but wow, now that I see the wind on this is a very intense system. Oh my gosh, yeah. So this would be a big system. Really, the next weekend is something that is another time frame we may really have to watch, because there's a lot of southwesterly flow here. There's going to be a lot of forcing with that jet streak that is going to move across. And you can see that patch of wind here. It's just trouble. It really is not. It's unfortunate for California to see this. But at the same time, we do need the rain. We could all use the rain, right? Because who knows what December will bring. You know, in California sense, in Oregon sense, you do not want a ridge to be in place for 3 or 4 weeks at a time. And so it's basically you take it or you leave it. You know, you take it when you can get it. So I would rather have us get a lot of rainfall now, because maybe in December we may not have as much. Who knows, right? Every winter is different back west. I am from the west, so you get what I mean. In the Midwest, it can go both ways, but our wet season is about from mid-October all the way through at least early to mid-April is about the wet season for California. But the bulk of the wet season is really January, February, and March. We get dry summers here back west, and our winters are cold and wet. So we have a more of a Mediterranean temperate climate versus areas like east of the Rockies. You can get rain in the summertime or in the wintertime. You can get it 365 days of the year. 366 during leap year, you know? So that's the concern here, especially the first initial atmospheric river. I mean, these are rainfall totals that are under 4 days. Some of these areas here on the Euro could get a foot of rainfall in a matter of 2 to 3 days, even 4 days. That's a lot of water. That's a lot of water. Okay. So yeah, if you are in the Northern California area, even in Sacramento and the Stockton area, if you're south of Stockton, like in the Central Valley, and in San Jose, the Santa Cruz Mountains, it's kind of like a double-edged sword here. That moves south by like 50 miles. It's going to be a whole different story for the Santa Cruz Mountains. But if this goes a little further north, some areas like even Monterey Bay might not get any rain at all until probably Friday or Saturday when that reinforcement comes through, and then you get more rain after that. But wow, where this AR sets up is going to be extremely important. It will mean the difference between some areas getting, say, 4 to 6 inches of rain, or getting maybe 1/10 to 1/4 of an inch, or nothing at all. So that's going to be the huge critical part of this, is where does this exactly set up? Models could only give us one partition of the forecast. The actuality on how this pans out is going to be another story. So now what really helps us out here, sorry, my ears are plugged up a little bit. Getting over a cold, we're fine though, right? So the AR on this, so letter A stands for, well, it's the first atmospheric river. This is going to be a strong event, all right? This is going to be fairly strong according to the European model showing us that. And it's going to last for about 3 days, and it's going to be strong for about 3 days, okay? If we look at the GEFS ensemble forecast, it's a little stronger, not as, yeah, it is. Actually, it's a little weaker by a little bit, but not by much. But notice this second right here, this second peak is going to be what we're going to need to watch. That's going to be the second atmospheric river for the weekend that is going to set up shop. And some of the models are going a little crazy, showing IVT, which is integrated vapor transport. And I'll show you that here on this model. There we go. I popped my ear so I feel better. I can hear again. Okay, so let me go over to, let me see if I can get, let's see. Here we go. This is what I wanted, right? Is this what I was hoping? Okay, is this, I want to make sure this is IVT. Yeah, this is what I wanted. Okay. This is perfect. So let's zoom in on this. And so what this is basically showing us is how much water vapor transport a given location is going to see. So the more vapor transport, usually the higher these numbers are, you're going to deal with more heavy rainfall and more wind forcing and everything like that. We'll get to the wind part of this in a little bit. You're going to want to see this. But look at just how much water vapor transport this thing is going to have. This low pressure system, you can even see the dynamics. This is quite extreme on a meteorological scale. Okay, so the redder the colors, the more significant. And this is all the way up. That's all the way up to 1,000 on the IVT scale. And as we go forward, you can see when this hits California initially, it's going to be about a 700 to 800 to almost 1,000, according to the GFS. If we look at the European model, let's play that through. Probably the Euro is going to be more realistic with a scenario like this, just because it's a Euro model. And Euro does a fairly good job for the most part. But look at where this stalls. So these numbers are going to be really high, and that really hits. That's really going to hit Northern California and Oregon with a ton of bricks. And then you can see the second piece. Now, this is the 12s, the European model. This has trended a little bit north with the low pressure being up here. And the IVT is a little bit more significant, I'm assuming. Probably in the range of 800 to 1,000, maybe almost 1,200 on the IVT, which is integrated vapor transport. Well, that's what IVT stands for. And this hits Central California. In other words, we are in atmospheric river territory through early next week. It is going to rain for a long time. And for reference, let's go to the Weather Channel. You're going to be amazed by this. Hey, the Weather Channel. Oh yeah, the Weather Channel is talking about it. So let me just go to let's go to Sacramento. So Sacramento, California. If we go to our 10-day forecast, why is it not working? There we go. We are under a freeze warning, to be quite honest. So, yeah. You can see there is rain every day. And then Sunday is that question mark on exactly how that's going to set up. Question mark there. There's a 40 to 60% chance of rainfall, but really likely through at least Saturday, we're likely to see the most rainfall with at least the first couple of ARs that move through, then maybe a third one by Monday, and then hopefully we will dry out, but that could mean some Thule fog issues, some Central Valley fog, depending on how the upper level pattern sets up. If we don't get any north winds, we could have more fog trouble ahead with that. And then, of course, across Oregon and Washington, you already know it's going to be raining every day. Hey, Pat, how are you, bud? Pat's Path Predictor. So, yes, now to the wind part of this. Everyone's probably curious about the wind. So, let's kind of do that. All right. So, you guys can see that. I want to make sure it's coming through well. Because the wind is going to be a really big problem here, especially as we get through tomorrow morning. Jax, check Santa Clarita. I will in a little bit after I show the wind part. We'll get to questions. All right, we'll get to questions. Yeah, low 80s in Florida. That's insane. That's insane. No thank you to 80s here in my area. We're going to be down in the mid to upper 20s tomorrow morning. We're going to be in for some really cold temperatures in the morning. So here's a look at the wind forecast, and I will tell you what, this is a pretty big wind event that is going to be setting up, especially along the Oregon coast. Look at these winds. These are winds that are 68. It's a little bit more impressive on the NAM, showing a couple of areas here of even winds of maybe 70 miles an hour. 70-mile-an-hour winds, perhaps. That is phenomenal. Yeah, look at that. Hurricane force wind right there along that front. Zoom in. Yeah, 77-mile-an-hour wind out of the south. That is incredible. And then let's go up here to Washington. This is what the wind is going to be looking like. This is, again, that big issue, that big threat for power outages, trees to come down, that sort of thing. The metro area in Seattle, though, however, is going to have winds, because here's Arlington. There's Arlington Heights over there. And you get down here towards Seattle, you're going to have winds between 25 to 35 miles an hour from the southeasterly direction. And then in the Arlington Heights area, it's going to be between 25 to 35 miles an hour on this particular model. When we look at the NAM, though, it's a little bit more stronger, getting into the 40s up here in Arlington, Mount Vernon, Cedro Woolley area. And then down here further south, Three Lakes, Granite Falls, Marysville. If you are in North Creek, it's going to be some intense southeasterly wind coming off these mountains. Mountain wave event actually is in the forecast. But especially look at Puget Sound here. This is sustained winds of 60 miles an hour coming in out of the southeasterly direction. That is some extreme winds. And then those winds do back off quite a bit once the gradient relaxes. But wow, tomorrow morning, not tomorrow morning, Tuesday night into Wednesday morning. That's what I was meant to say. That gradient is going to be really tight. Tight easterly wind gradient. And if we back it out again on the NAM model, this is pretty concerning right here. You're talking about winds. The coastal headlands here, especially Port Orford, could see winds perhaps of 60, maybe 70 miles an hour with those wind gusts. Look at these wind gusts. 90 plus miles an hour. And even off the coast here, almost 100-mile-an-hour wind gusts. So that is going to do a lot of damage. But you can really see that low. That is, yeah, I know. Speakeasy, yeah. These winds are going to be insane. Serious winds. So yeah, that's what that is. So now, why are these winds going to be strong through these canyons? Because I wanted to mention this briefly too. Here's the Arlington Gorge, this canyon area. And as you get these winds that come through the canyon here, they actually funnel down. So let me actually show you how this works. So you actually get your winds that come through these canyons. They come through here. They might come this way as well. They they pour through and they get funneled right through these canyons, especially Arlington Gap. And what ends up happening is that it's like water going through a narrowing pipe. When you squeeze all that air in through these canyons on top of a very tight pressure gradient, you could get wind gusts exceeding even stronger than what models indicate. Models do not do the best job at this, which is why I think some of these canyons here, not illustrated on the models, like Arlington Canyon right here. Here's another little canyon, and here's another one down here. Primarily these 4 canyons that I've circled in yellow could have wind gusts exceeding 70 to maybe 80 miles an hour. Could not be surprising if we even have a peak wind gust in some of these areas exceeding 90 miles an hour. That would be enough to really blow down trees, power lines, probably blow a roof off of a building for sure with winds that are this strong. Very familiar with Arlington. Okay, so you kind of know what I'm talking about then with these gap winds. So you can think about these winds that really funnel through. And here is a canyon. So you can see these winds just funnel right through. Not as strong here in Darlington though, but you know, when you get past Oso and then Hazel, Trafton, Arlington Heights, right in here is where the wind could be really strong. And then Cokeville, then Cedro, Woolley area, that little cute town. Look how cute that town is. Reminds me a little bit like Lodi, doesn't it? Has that little grid-like structure. And winds there could be pretty strong. You're very welcome, yeah. And let's just say I don't rarely hear my friend Keith Evans, that's in chat now, cuss when because we were talking about this last night, and he was like, holy, you know, the SH word. And I'm like, oh man, this is, when I hear him cuss, you know it's serious. You know it's serious. And he was even saying this could be even as strong, if not stronger, than the Columbus Day offshore windstorm. Just because of the way the gradient is. And yes, Keith, look at these winds. I mean, look at this. You're seeing it for yourself on the modeling. Look at this, 75, even 80 miles an hour on some of these ridge tops. And this is on the HRRR model. Look at down here, look at this. 80 miles an hour there. Look at 81, got 83, wow. Actually, winds there could peak at 90 miles an hour. 90 miles an hour. What about Camino Island? So Camino Island, that's probably in the Seattle area. Yeah, that's this area. Okay. So that area, you could have wind gusts between 50 to maybe, let's see what the NAM is showing. Oh yeah, you're going to see wind gusts over 60 miles an hour. Between 55 to 70 miles an hour is a rough range of where you're going to see your winds. Let's see winds at different elevations though. Different layers. Let me bring that up. Yeah, look at the winds at 2,000 feet. Actually, yeah, here it is. Yeah, look at these winds, Keith. Even 2,000 feet, look at this. 70 mile an hour winds. What's up, Kate? Kate E. Hey, you're in Stockton. You're local. You're local. I'm north of Stockton. Probably not very eventful for wind or rain for your area until probably Friday or Saturday. Now, areas like Sacramento to the north, it's going to be like tomorrow afternoon. Yeah, let's go to Mount Shasta. Let's see what that area looks like. Since we looked at we'll go back and forth getting to your guys' questions because I pretty much covered everything. Unless I missed anything. If I did, just let me know. So the Weed area, that is, yeah, oh wow. This area could have some pretty insane south winds. This is a really windy prone area. You could have winds sustained even at 40 miles an hour, 35 to 45 miles an hour. And wind gusts there could exceed 75 miles an hour. Right on the leeward side of Mount Shasta, Mount Shasta could have gusts over 90 miles an hour perhaps. That is pretty significant right there, that wind funneling right through. And then, of course, for Southern California, because someone wanted me to show Southern California, it's not going to be a big windstorm at all. Unless you're, like, on the very tops of these mountains, you may get gusts up to 30, but, like, at least throughout Wednesday, you're not seeing much in the way of wind. Yeah, you're not going to see much at all. Oh, by the way, Keith, I wanted to show you this. If you're still watching, Keith, let me know if, that you're watching. You need to see the latest European model. Okay, so this is the 18Z Euro. We'll look at this actual pressure here in a second, but look what happens for California. So we get reinforced with that atmospheric river, and then guess what happens at the end of the model run? Look at this. 986 millibar system hitting Northern California. Look at that. Yeah, that's for Northern California. Yeah, that's another system. Could be very active next week through Sunday and even Monday. And actually, you know what I forgot to show you all? Let's take a look at our weather warnings. I wanted to share with you all this. You don't ever see a hurricane force wind warning very often. If we actually click on this, yeah, look at this. Tuesday, winds becoming south 50 to 60 knots with gusts up to 70 knots and very steep and mountainous seas up to 33 feet. Up to 33 feet. Wow. That is some serious surf. Oh yeah, we could, Keith, depending on the latest model runs. Yeah, so there's a hurricane force wind warning. This is, theoretically, if you guys want to call it a hurricane, it could be almost like a hurricane. But yeah, blizzard warnings in the Northern Cascades. Wow. And this is where my friend lives, right in here, this high wind warning. This high wind warning, blizzard warning, you got it all. I'm even surprised actually Seattle's under a wind advisory. Should be a little, it's be a little stronger than that. And a winter weather advisory issued for the Olympic Mountains. And of course, storm warnings along the Washington coast. And yes, for our area, there are winter storm warnings issued. We're under a freeze warning, by the way. Freeze warning. Lovely. I'm going to freeze. I'm going to be like an ice cube. So yeah, winter storm warnings, even look at this, cold weather advisory. You don't hear that very often. I guess that's new for the National Weather Service. But yeah, look at this, flood watches up there towards Fort Bragg, Ukiah, Lakeport, Port Arena. And this is not good. This is not good at all. Oric 3D, sorry if I'm scaring you. We have to be afraid of this storm. We really do. So any questions, anybody? I found out about it pretty quickly once it came out. Oh, you're in Northern California. Yeah, well, what part of Northern California, Oric? It's awesome to get locals. Actually, well, I don't really want to promote this channel with my other channel, but I do have a Weather Watch West YouTube channel. I'm probably going to be posting on that tonight on this same system. Because, yeah, this is making a lot of headlines. In fact, let's actually go and look at the pressure on that. See if this actually did trend stronger. Oh, wow, Keith Evans. This is down to 942 millibars on the euro. It was a little stronger in the last model run, so it is not showing it as strong as it did before. It's about a millibar weaker. But it's still extreme. It's gonna happen. It's gonna happen. Well, look how quick that deepens. That really deepens. What's up, Savion? How are you doing? What's up, Diana? How are you doing? Welcome to the stream. By the way, if you guys are new to this channel, make sure you do subscribe. I don't rarely cover the West very often. Well, I cover everyone, where everybody lives, but wow, this is really a focus on the western half of the United States because of how active how big that storm is going to be. Let's see if this is actually going to impact Utah. Nope. Nothing in Utah. Nothing in Utah. It's actually going to be really warm there. Warmer than average. That's why this system is also going to get deep. Is that ridge is really going to build over the Four Corners region. Keith, you want to see how strong this is going to be? Oh, you want to see how strong this is going to get? Look how strong it's going to be. Depending on what model. Actually, let's use the Canadian version of the high res. Yeah, look at that gradient. Look at that surface high. Serious high pressure system. Yeah, down to about 940 millibars. Morris Jackson, what's up? So yeah, the pressure is going to get down to about 939, 942 millibars. That's the expectation, is that's how low the pressure is going to get. But it's about the gradient. Pressure change over distance. And look at that gradient. And I bet you Keith Evans is going to say, holy cow. Oh my gosh. That is an insane pressure gradient. That is insane right there. Yeah, by the way, that's a 27. Yeah, that's a 27.8 millibar system. That's a very low pressure system right there. What about Vancouver, Washington, just north of Portland? Okay, you're... Oh, there's a Vancouver. Okay, I thought Vancouver, Washington was north of Arlington. Okay, it's down here. So Vancouver, Washington, let's see what the pressure is going to be like there. It's going to get as low as about 2944 inches in mercury. That's the lowest it's going to get. But remember, don't let that fool you. Gradient. The gradient is going to be pretty significant. I mean, Astoria in Oregon, 2929, and you go to Portland, it's 2945. That's a very tight gradient. Is the mainstream news downplaying the storm? I don't know if the mainstream news is downplaying it. Are the winds going to in Eugene? Oh, right down here. Okay. Let's see what the wind forecast is. You're going to get more of a southerly wind. So depending on what part of Eugene, if you're on the southern side of it, you'll probably get winds that are stronger, wind gusts, that are about 30 to 40 miles an hour. So doesn't look like the winds there will be a big issue. Maybe actually as the front rolls through, you could get gusts up to maybe 50 to 60 miles an hour right as the front is passing through. And then the back side of the storm rolls through. Actually, some of the storms, if any thunderstorms do develop over that area, you could have locally gustier winds. But the strongest, maybe 40 to 50 miles an hour. I don't think it's going to be nothing like along the coast. $70 is just a stiff breeze in Oklahoma. Boy, you must be very resistant to the wind. Believe me, 70 is pretty insane. But wow, this, I mean, I'm going to play this through for you all to watch. And I want you all to just to see this. So this is basically right about now. All right. Watch the low deepen. Just watch it deepen. Okay. Here we go. Watch how quick it really does. And that gets down to 940 millibars. Okay, can you check Santa Clarita? All right, so Santa Clarita is not going to get anything significant. If you get any rainfall, it is going to be Monday next week. If anything, you get rain early next week. Especially if this system does move towards kind of the lowest pressure moves through Northern California. We'll see about that. But it doesn't look like you're going to get a whole lot. We look at the 12Z model run, you do get some rain. And that's all you're going to really get. You're not going to get hardly any more at all. You guys are pretty far south, okay? It takes an El Nino and a southern dip of the jet stream for you to really get some needed rain. But here's how it's going to set up. Let's look at the 500 millibar jet stream. Watch this, and this is your favorite, Keith. This is your favorite right here. Look at this. Look at that jet streak. And actually, we could even use... Yeah, let's use a 300 millibar jet. Look at this. Look at that outflow channel. Yeah, your trees are really tall, Keith. Yeah, 200-foot tall trees. That's going to be a problem. What's up, Dominique? How are you doing? Yeah, this is looking pretty bad. That is a nice looking baroclinic jet right there. That outflow is really stout. And this is what it looks like on a water vapor standpoint. You can see the cloud cover, the moisture that whole channel. That is a big system. The way the winds whip around here in Western Washington can get pretty crazy. Oh yeah, for sure. Especially with that easterly wind. Oh, you're in Western Washington? So you're like, oh yeah, well, in the metro area, I'm sure. If you're over here in Neha Bay, oh boy. Oh boy, that's all I gotta say. I'm doing pretty good, Dominique. Excited for a storm that could actually bring us more than a half an inch of rain, perhaps. Hopefully the atmospheric river can head further south and we can get some more moisture here. Hi from Malaysia. How is the sky in Oregon now? My crippled friend Deborah is home alone there. It's right now, look, we are seeing some scattered showers and thunderstorms moving over that area. But it's going to get, the weather's going to really deteriorate because you can see where that surface low is. But I hope you're ready for this, Keith. I hope you're prepared. You have the flashlights ready. Because you're going to, I bet you, I predict you're going to lose electricity, and it's probably going to be out for at least a week. It could be out a little longer than that, just depending on how your power grid is set up. Hi, I am right in the path of this thing, 50 miles north of Seattle. There are many tall trees near me. Oh, 50 miles north. So let's see. You're north, so... Oh, wow, you're in the Mount Vernon area. So, wow. Yeah, you're in the Mount Vernon area. Wow, you are really far north. So let me see what your winds are going to look like. Boy, if you're right here on this particular model, you could have 30 mile an hour sustained winds. we look at the NAM, you could still have about 30-mile-an-hour winds. That's what it looks like. What about Idaho? I live in Moscow. So you're in Idaho. So you're over here. Oh, wait, no, hold on. Okay, you're right here. Okay, perfect. So that area, you're not going to get really severely affected. You are going to get some wind. Might get some precipitation, but the majority of it is going to be like just west of you over much of Washington and the Cascades. You're very welcome, KDM. Keith will definitely lose electricity. Since I live close to Keith, I could as well. Yeah, I'm in a pretty remote area. We lose power a lot. Once was for 8 days. Jeez, 8 days. That's incredible. Yeah, make sure you get a generator, Keith. I'm sure you can get a generator for, I don't know how much generators are there. State of Washington may be a little different, is different than California. But I would get a generator, especially for your refrigerator. You do not want food to go bad, because it'll go bad in 8 days. I can say that for sure. It'll go bad in 8 days. But I wanted to show you all the wind gusts. Look at the wind gusts around this thing, this low pressure area. 103-mile-an-hour wind gusts. And Keith is like, holy cow. I'm really curious of what the surf is going to look like. I haven't seen the waves in a while. See what the waves are going to look like. Oh my goodness. Look at the waves out here. 34 feet. 34 to 36 feet. See what the... Oh my gosh. Look at this. 42-foot waves. Oh my goodness. On this is on the RDWPS. Another wave model. Serious. Oh, good. You have a generator? Good. Very northern California coast here. Whatever happens, happens. It's 2024. Yeah, you're way up over here then. Potential for 50-foot waves. Yeah. Was this low originally a typhoon? Let me actually look at the history. I don't think it was connected with this low pressure center, but let me go back. No, it was not. It was not a typhoon at all. Because if we play this through, it's an area of low pressure that formed. It formed down here. Yeah, so this is basically where it originated from. So it originated from this low down here. So if we look actually at the past, you can see where the low is. It came all the way from down here. And as we play it through, and then it forms. See how quick it's forming? That's where it's forming right now. What should I expect in Spawnaway? Can you... I can... Okay, let's see. Spawnway. Spanway. I don't think there's such thing as a Spanway. Maybe a little town. All right. Spanway, Washington. Okay. Spanway. Spanaway. Spanaway. There we go. That's a little bit better. Oh, there's a live camera. Believe it or not, I hit a live camera. So let me... So Spawnaway right there. You're going to have some serious wins. For sure. Oh, yeah. Especially to your south. Again, that mountain wave event can make things really interesting. There's a narrow area that may not get winds at all. Some areas could get some intense winds that could have sustained winds greater than 60 miles an hour, depending on location. And there could be some areas like here that might get a little bit of a lull in the wind. The wind actually may not be that strong at all. It just depends on that direction, where you're sheltered, where you're wind sheltered at. But I'll tell you though, for sure, Arlington is going to get winds from the start to the finish. Severe erosion could occur at coastal towns. Oh, yeah. Oh, yeah. Big time. See, our sun is just setting. Our beautiful sunshine. Going down at 245 degrees already. In direction. You could actually see it already setting that far over to the left side of the horizon. That's incredible. Another 5 more degrees to go, 6 more degrees before we reach the lowest sun angle of the winter season. The shortest day. Do you like let me know in chat. Do you guys like when it gets dark early? I'm sure none of you like it when it gets dark early. It feels really late though. It does, but it's only 4:45. Onalaska, Washington. Let's see. Onalaska, Washington. Let's see. Little tiny town. Wow, little baby town. Very tiny, small area. So for that area, let me see what your winds are going to look like. So yeah, your winds are going to be fairly elevated, similar to other areas. You could have winds about 20 to 35 miles an hour with wind gusts over 50, easily over 50. Bomb cyclone of the century. Yes, I did see a post on the internet saying that this could be one of the strongest cyclones of the century. If it gets down to 940 millibars, I mean, I don't think anyone in Washington in their lifetime has had a pressure down to 940 millibars off the coast. No, it's not going to make landfall on the coast, but its wind field will definitely touch the coast. The storm of the century is more for like an article look. You search it up online. Let's actually look at this. Let's do bombing cyclone. You go to news. I mean, yeah, look at this. They're even talking about California here. I mean, you look it up online, you'll see it here within the last... I mean, you can see it here. They're even talking about it. Oh my gosh. You want to know how much rainfall this is actually going to deliver? 8 trillion gallons of rain on cities like California. Northern California, Southern Oregon combined could have over 10 trillion gallons of water. 10 trillion gallons of water. Yeah, this particular system is set to experience an astonishing pressure plummet of nearly 70 millibars in just one day. Yeah. Yeah. Let me check after I'm done streaming. Only another 10 or so minutes, maybe 15 minutes. Sorry about that. Yeah, but 70 millibars in just one day, reaching a low of 972 millibars. To put this into perspective, how such pressure readings are typically associated with a Category 4 hurricane. Category 4 hurricanes. 70 millibars in just one day. I mean, wow. So just to put that into perspective, tons of water and tons of wind. So in some context, this could be considered a hurricane, but will not have a satellite presentation of a hurricane. It will be a cyclone. But wow, it is going to have that representation of a hurricane force wind gusts. How bad is 55 mile an hour winds? Pretty bad, Morris. Hey, Justin! What's up, brother Justin? Hey, do you want to VC on Discord and talk about this system on the live stream? I want to hear your thoughts about this. This thing is going to be a substantial one. Oh, okay, Justin. Sounds good. But yeah, what are your thoughts about this, Justin? 70 to 71 millibar drop in pressure in 24 hours, that is expected. Oh, yeah. And I'll tell you, Justin, imagining if this did hit Northern California like the Bay Area. Oh, my goodness. If this hit Northern California. Winds will be over 100 miles an hour at Donner. I don't think they'll be that strong, but yeah, they'll be very strong in the higher elevations of the Sierra. I forgot it's still 2024. What's up, Trey? But yeah, this is going to be a big storm. This is going to be a monster. And sorry I'm smiling, but like, wow, this is a beast. This is going to be the beast of all beasts. It's like a bratwurst. You know, it's like a bratwurst of a storm. And look at the low-level winds along that front. Why does this National Weather Service say only 45? So if that's in the Seattle area, or depending on what NWS office you are tuning into, the NWS is more generous. Okay? They're going to be more generous because that's the National Weather Service. I'm going east. Okay, you're going east, so you're probably going to avoid it. You're going to avoid the storm. Abby, what's up? Hey, David. Happy belated birthday and 6 years in the making of YouTube content. Consider this a belated birthday gift. Thank you, Abby. Yeah, me and Abby were talking about the storm last night, and yeah, she was like, this is going to be a big one. This is going to be big. And look at what it looks like on the simulated satellite imagery, Abby. Look at that curly Q. And I want to, just FYI, Abby, pressure is going to drop 70 to 71 millibars in 24 hours. That's what some of the, yeah, I mean, 70 to 71 millibar drop in pressure in 24 hours. Actually, I need to make her mod since we're well connected again. Especially you have a Tempest. Oh wait, no, you didn't. You don't have a Tempest, or you did have a Tempest. But yeah, this is what the storm is going to look like, and it is just going to go boom. I did give this a name, not because of Abby in the chat, but I'm thinking about only for the Pacific Northwest, for storms like this, I'm thinking about naming them, and this would be Winter Storm Abby. The next storm would be Brendan. Then the next storm after that would be Carly, and then it would be Don or Doug. I'll have to figure that out. So yeah, you got to name storms like this that are intense. And boy, Winter Storm Abby is going to be a monster. Going to be pretty strong. Wow. Look at this monster. It's a monster. All girl names. Love it. I don't try to intend doing it like that, but all right. Let me see what the wave model looks like on the Euro. Oh yeah, look at the maximum individual wave height. Who likes 70-foot waves? 70-foot waves with this monster. 70-foot waves. Up to 70-foot waves. Let's see what the Wave Watch 3 says. Yeah, that's about 34 feet right there. But wow. Yeah, 70-foot waves, those are killer. Those are killer waves right there. That's totally killer. My power doesn't go off. I'm running on lithium batteries. Oh, really, David? So maybe your generator does. Pretty clever. Until it fails, maybe. Then it's not so clever. But yeah, I wanted to show you all the temperature gradient with this as well. Look at that. You can actually see where the arms of cooler air are moving in to the circulation. In fact, if we do look at the 925 millibar temperature, you can see where it actually occludes, and you actually get like a hurricane like swirl. Joshua, there will certainly be some storm surge. In some of it depends on how the storm, what the angle of attack of the actual winds along the coast will be, but most likely you'll have at least 1 to 2 feet of storm surge. Yeah, the long, narrow tail is the atmospheric river. Oh, yeah, for sure, Abby. Oh, also, Abby, since you're here, did you see the Euro on what comes after that? Did you see what comes after that? So we get this, it slams, and then look at a third system on Saturday into Sunday, maybe even into Monday. I'm not really bald. I do have some hair. I didn't go bald this time. Technically, I'm not bald. I have about that much. Maybe like 1 or 2 hundredths of an inch of hair. But yeah, Northern California. Thank you, Enlist Beauty. Glad you like the haircut, the hairdo. If anyone watched my King Tide live stream on Saturday, what do you guys think of that? To me, the King Tide could have been a little bit more better, but it didn't end up as high as I thought. The predicted tide was like 6.8 feet, but it only ended up being like 6.6 feet. Thank you, Sunways. I don't know if you're still here, Abby. But yeah. What do you think of that first, second, and then a third system? By the time this is all said and done, well, of course, this is the 18Z. It only goes out to... This only goes out to a little over 5 days out. Actually, 6 days. And you can see, yeah, all that rainfall. Woo! Oh my. Sanja. Yeah, each weather channel has their own way of forecasting. Oh yeah. That could be another one though. That could be a big system. And look at oh my gosh, and I'm seeing the winds for the first time too. It's another February 4th windstorm. Yeah, that actually is, because that's 10 a.m. Yes, it is, because it's Sunday. It is actually happening on Sunday. 10 a.m. Sunday. There is 32, 33 mile an hour winds. That would be a big storm. Relative to California. Yeah, gusts for your area would be about 45, Abby. Not for my area. They would be 50, 52 mile an hour wind gusts. That would be Winter Storm Brendan right there. Letter B storm. It's a lovely little small storm though. It's lovely. All right. Any questions, anybody? Any questions? I'm probably going to head off here really soon because my grandma needs my help with something. So it'd be Brendan. Well, my names that I name storms are entirely different. Dude, why did you shave your head? Because my hair was getting too long and it was bothering me. It was bothering me. My grandma doesn't like my haircut. Believe me, she's like, why did you get it cut that short? Yeah, okay. Let's see. Why does everyone say that? Yeah, TG, yeah, I saw your question. Sorry if I missed it up there. Chat's going a little elevatedly fast. So, yeah, this is a fall storm, and this is pretty unusual for mid-November. Come on, it's not January. It's not January. So, yeah, this is pretty unusual. It's all right, TG. Maybe it could be the TG storm. No, I'm just kidding. How will you stay warm now? You're probably asking me, Spa Man. Oh, I'm going to stay warm with my heater on. It is going to get pretty cold tonight. I'm loving it though. I love the cold. I can take the cold year round. It is supposed to get down. Let's see. How cold is it going to get? Is this, man, this is not correct. Or am I looking at this wrong? This is, wow. Why do they have a freeze warning in effect if it's not going to get that cold? That's crazy. They have a freeze warning and yet it's not going to get down to 30, even 30 degrees. Okay, National Weather Service. What's up with that? Cloud cover can play a factor. That could be okay. That might be the yeah, okay. Then they should have thought secondly about issuing that freeze warning. So the freeze warning may not verify, actually. It broke 31 tonight. Yeah. Hey, Terry, Tony, how are you? Good evening, David and Piers. How are you doing? It was saying like 30 to 31 degrees, and it changed to like 30 to 34 to 35. A frost advisory. Yeah, TG. It might be changed. I was hoping for it to, I want to see it freeze. My body has not felt the freezing temperatures yet, because I was in Santa Cruz when it last froze. What did it show on the... Yeah, it's been trending warmer. That's crazy. Yeah, see, yesterday it was it was looking like it was going to freeze. Now it's really trended warmer. Interestingly, it actually has. The HRRR is coming in, though. How exciting. Oh, I do remember that, TG. That was crazy. Yeah, up in Oregon. Yeah, that easterly wind. Yeah. All right. So I think I'm going to call it a night. I think that's all that there really is to talk about for this storm. Because tomorrow it's going to be a bombed out cyclone. It's going to be pretty strong. So I might go live tomorrow. Yeah, I don't think I'll have time tomorrow. Actually, maybe tomorrow night I can go live. The system would already have bombed out, and the front would be right along the coast. We'll probably do a special winter storm coverage. Actually, I will do that because that's part of my job. So we'll probably go live tomorrow night doing like maybe a 1 or 2 hour, actually 2 or 3 hour live storm coverage for Oregon and Washington. That's probably what my plan is going to be. But anyways, thank you all for tuning in. Please share this, subscribe. I still actually have to make a video for my other channel for localized people that live just across the West. All right, but anyways, thank you all for tuning in. Share, like, and subscribe, and I will be back with you more tomorrow with another update on this system tomorrow night. Tomorrow night, not tomorrow afternoon. All right? Peace!